Hello everyone, in this video you will learn the difference between single mode and multi-mode fiber cables. Optical fiber cables are based on the idea that light can be confined within a bent glass rod by total internal reflection. Nowadays, optical fibers are used in carrying telephone, television and computer signals from one place to another. If you want to know the structure of fiber optic cables and what exactly are these cables in detail, you might go watch my video with the link at the top of the screen. The two primary types of optical fiber cables are single mode and multi-mode. Single mode fiber uses extremely thin glass strands and a laser to generate light, while multi-mode optical fiber cables use LEDs or light emitting diodes. Single mode means the fiber enables one type of light mode to be propagated at a time, while multi-mode means the fiber can propagate multiple modes. Actually, there are some misconceptions on the difference between single mode and multi-mode fiber cables. So let's see the common misconceptions. It's important to remember that there is no way to distinguish between single mode and multi-mode optical fibers with the naked eye. The standard optical fibers have cladding around the core that brings the diameter of the optical fiber itself to 125 micrometers. When you put a connector on an optical fiber, you are primarily seeing the cladding and any integral protective coating. The terms single mode and multi-mode also have no relation to the number of optical fibers in the fiber optic cable you are running. It's possible to have a cable containing 144 single mode optical fibers, and it's also possible to have a cable containing the same 144 multi-mode optical fibers. So the differences between single mode and multi-mode fiber optic cables mainly lie in fiber core diameter, wavelengths and light source, bandwidth, color sheath, distance and cost, right? So let's start from the difference in core diameter. Single mode fiber, or in short SMF, core diameter is much smaller than multi-mode fiber. Its typical core diameter is 9 micrometer, even if there are others available. For reference, a human hair is closer to 100 micrometers. The core is surrounded by a cladding that brings the overall diameter of the optical fiber to 125 micrometers. And multimode fiber, or in short MMF, core diameter is 50 micrometer and 62.5 micrometer typically, which enables it to have higher light gathering ability and simplify connections. A larger core means multiple modes or rays of light can travel down the core simultaneously. Just like single mode, the core is surrounded by a cladding that brings the overall diameter of the optical fiber to 125 micrometers. The smaller core size in single mode leads to lower attenuation and therefore longer transmission distances and higher bandwidths. The physics here is straightforward. A smaller pipe means less signal reflection. The attenuation of multimode fiber is higher than single mode fiber because of its larger core diameter. The fiber core of single mode cable is very narrow, so the light that passes through these fiber optical cables is not reflected too many times, which keeps the attenuation to a minimum. Now let's go to the difference in wavelengths and light source, another component of difference between single mode and multimode fibers. Due to the larger core size of multimode fiber, some low-cost light sources like LEDs or light emitting diodes and VCSELs or vertical cavity surface emitting lasers that works at the 850 nanometer and 1300 nanometer wavelengths are used in multimode fiber cables, while the single mode fiber often use a laser or laser diodes to produce light injected into the cable. And the commonly used single mode fiber wavelengths is 1310 nanometers and 1550 nanometers typically. Another difference is their bandwidth. So when it comes to bandwidth, single mode is the clear winner. Single mode cables support brighter, more power light sources with lower attenuation. Plus, a single light mode provides theoretically unlimited bandwidth. Multimode, on the other hand, relies on the transmission of multiple light modes with less brightness and higher attenuation. This caps the bandwidth and leads to 5 grades of multimode fiber, each with different bandwidths and distance capabilities, as you can see clearly from the table. The other difference is in the color of the single mode and multimode fibers. So according to the TIA 598C standard definition, for non-military applications, single mode cable is coated with yellow outer sheath and multimode fiber is coated with orange or aqua jacket. The other one is distance. Fiber transmission distance is largely dependent on the electronics and their light output. But in practice, we find single mode also outperforms multi-mode. Single mode fiber supports short distance transmission and long distance transmission regardless of signal bandwidth and resolution, such as 1080p, 4K, and 8K videos. Most electronics will transmit up to 10 kilometers over a standard single mode cable. Multimode, on the other hand, has a much shorter maximum transmission distance that's affected by cable grade. We typically find the maximum distance between 300 meters to 550 meters. Generally, single mode fiber is suitable for long distance applications, while multimode optical fiber is designed for short distance runs. The final difference is in the cost. Given the clear advantage of single mode fiber, you'd think single mode cables will be more expensive than multi-mode cables, and that's surprisingly not the case. Single mode fiber is more efficient to manufacture, leading to an average of 30% savings over multi-mode fiber. The catch is single mode electronics tend to cost more due to stronger light sources and more intricate optical processors. The actual cost varies between device and manufacturer. However, 30% tends to be the average cost difference. Single mode versus multi-mode fiber cost depends mainly on the optical transceiver cost, system cost, and installation cost. So according to the optical transceiver cost difference compared to single mode transceivers, the price of multi-mode transceivers is nearly 2 or 3 times lower. And regarding their system cost, to utilize the fundamental attributes of single mode fibers, which are generally geared towards longer distance applications, requires transceivers with lasers that operate at longer wavelengths with smaller spot size and generally narrower spectral widths. These transceiver characteristics, combined with the need for higher precision alignment and tighter connector tolerances to smaller core diameters, result in significantly higher transceiver costs and overall higher interconnect costs for single mode fiber interconnects. Fabrication methods for VCSEL based transceivers that are optimized for use with multimode fibers are more easily manufactured into array devices and are lower cost than equivalent single mode transceivers. And their installation cost. Single mode optical fiber often costs less than multi-mode fiber. When building a 1G fiber optic network that you want to be able to go to 10G or faster on eventually, the savings on the cost of fiber for single mode saves about half price. Now let's summarize the differences between single mode and multi-mode optical fiber cables. So generally, single mode optical fiber cables are designed to carry only a single mode of light, whereas multi-mode optical fiber cables are designed to carry multiple modes of light at once or simultaneously. Single mode optical fibers are used for long distance transmissions of signals generally, and multi-mode optical fibers are used for comparatively shorter distance transmission of signals. And there is narrower modal dispersion in single mode optical fiber cables, whereas a large range of modal dispersion is possible in multi-mode optical fiber cables. Single mode optical fiber cables have a smaller core of about 9 micrometers in diameter, whereas the core diameter of multi-mode optical fibers is 50 micrometers or above. In single mode optical fiber cables, there is practically no or less degradation of signals, whereas in multimode optical fiber cables there is much more degradation of signals. Handling or manufacturing single mode fiber optic cables is quite difficult as coupling light becomes difficult with distance, whereas it's easier to manufacture and handle when it comes to multimode optical fiber cables. Not only the cable cost, but on average, single mode transceivers are costing 1.5 to 4 or 5 times the cost of the multimode transceivers, depending on the data rate. Whereas multimode optical fiber cables for usage in short distances are more cost effective compared to single mode fibers. Single mode fibers can be classified as the OS1 and OS2 types, having applications at wavelengths typically at 1310 nanometers and 1550 nanometers respectively, whereas the class of the multimode optical fibers are classified according to OM1, OM2, OM3, OM4, and OM5. Single mode fiber cable can carry signals at a much greater speed, whereas signal speed is relatively slower in multimode fiber cables. A laser or laser diode is used in single mode bandwidth devices to create light that's injected into the cable. And a light source for multimode device is generally an LED or a laser. And finally, single mode fibers have higher bandwidths compared to multimode fibers, as much as 100,000 gigahertz. Thanks for watching. Don't forget to subscribe.